Today, the majority of React projects is developed in TypeScript instead of JavaScript. And there are good reasons for that. TypeScript's static typing can make developers more productive by providing better autocompletion and error detection. This video will give you an overview of TypeScript and how to use it together with React. Topics we will cover are basic type declarations for numbers, strings, booleans, arrays, and objects, so-called type aliases and interfaces, which allow us to store type declarations under a name, declaring parameter types and return types of functions. Furthermore, we'll look into generics and type assertions. Let's dive in. In TypeScript, data types may be specified explicitly or inferred by the development environment. And this can be helpful during development. It can lead to much better autocompletion because the development environment knows the type of every variable or property. And it can more easily detect errors, for example, when types mismatch or when there is a typo in the code. The TypeScript website has a playground that we can use to try out the language. Open up the TypeScript website and click on Playground. Here we can write and run TypeScript code. I will be using this playground for demonstrations throughout this video. Let's take a look at some basic types in TypeScript and how we can specify them. In particular, we will cover booleans, numbers, strings, arrays with specific types of items, and objects with specific properties. We can specify types when declaring variables by adding a colon followed by the type after the variable name. Here we have 3 different variables with 3 different types. However, in many cases, TypeScript will actually know or infer a type automatically. For example, from an initial assignment. We will not need type annotations in this case. And indeed, we could leave them out in this simple example. We can also declare types for arrays. Here we see how to declare that a variable refers to an array of strings. Subsequently, we can push some strings into the array. If we would try to add a number, TypeScript would show an error. There's also an equivalent alternative notation, which is a little shorter. The item type followed by square brackets. In practice, you will probably encounter both notations. Furthermore, we can declare the structure of objects in TypeScript. Here, we're declaring that the variable todo refers to an object with 3 entries: ID, title, and completed. The declaration looks quite similar to the regular object notation in JavaScript. Later, we'll see how we can store a declaration like this under a name, for example, by creating a so-called interface. Bringing all these type declarations together, we could declare an array of to-dos like this. Here, the variable to-dos refers to an array of objects, and these objects all have specific properties. Let's try to actually assign an array with some entries to this variable. TypeScript knows that this array should contain objects with specific properties. It will show corresponding warnings and help us out with autocompletion. And it will also warn us about misspelled property names. As another feature in TypeScript, we can define so-called union types for variables that can be one of multiple types. Here we see a variable named width, which can be either a string, a number, or undefined. In some cases, we may want to relax the type checker, making it less strict. If we declare a type of any for a variable, we're allowed to access arbitrary properties. Here we can access the value property of the name input, which would not be allowed without at least some form of type declaration. Using any can be especially helpful when you're starting out with TypeScript, or when doing some quick experiments, but should usually be avoided in the long run. Now let's have a look at type aliases and interfaces. Type aliases and interfaces are similar techniques that allow us to store a type declaration under a name. They are most commonly used to describe the structure of objects, as we can see in this example, which describes the structure of a to-do. Note that, just like classes, type aliases and interfaces should be capitalized. Here we see how we can achieve similar things with interfaces and type aliases. In general, type aliases can be somewhat more flexible and easy to use, but there is not a big difference. I will be using type aliases in my videos. Once we have declared a type alias, we can use it like other types. Here I'm starting out with an empty array of to-dos, and I can push a new entry making use of TypeScript's autocompletion again. Now let's look at function signatures in TypeScript. Here we see how we can specify a function's signature. The example functions here receive some text and a maximum length, and they return a shortened text. The parameter types are declared directly after the parameters, and the return type is declared after the parameter brackets. This is true both for function statements and for arrow functions. If a function does not return a value, we can make that explicit by declaring the return type as void. In React, we may have to deal with event parameters when writing event handlers. If we create inline event handlers, the type will be inferred automatically. But if we declare an event handler separately from the template, we may have to provide the correct event type. In the case of a click handler function, the event type would be a mouse event, which could be imported from the React package. If we have declared the correct type of the event, we could access typical members of the event type, like stop propagation, or we could find out the screen coordinates of a mouse click. Some common event types in a React application could be form event, for example, for a submit handler, change event for inputs, and mouse event, for example, for clicks. When working with TypeScript and React, we will also encounter generics. Generics are type declarations that can receive more specific type information when applied. And this extra information will be supplied in angle brackets. For example, array is a generic. The example here shows an array which will contain strings. As another example, React's useState can be used as a generic. Here we're specifying that useState will handle an array of to-dos as its state. The variables to-dos and setToDos will automatically have the correct types. Furthermore, React's event types can be used as generics. The declaration we see here specified that this event handler will process a change event which belongs to an HTML input element. And therefore, we can access event.target.value. Type assertions come into play when we know more about an existing object's type than TypeScript can determine on its own. In this case, we can use the as keyword to let TypeScript know about our additional knowledge. This code snippet assumes that there is an input element with the ID nameInput on the page. Of course, TypeScript wouldn't know about this, so it won't let us access nameInput.value. TypeScript tells us that nameInput is possibly null. We can rectify that by using the as keyword, telling TypeScript to treat the value as an HTML input element. Then TypeScript will allow us to access the value property. If we don't want to look up the correct type in a specific scenario, we could also combine as with any as a quick and dirty solution. So far, we've gotten a good understanding of the basics of TypeScript. Let's briefly go through two more small topics. First off, the build process. The TypeScript code rewrite will not arrive in the same format at the user's browser. In fact, browsers only understand JavaScript, not TypeScript. During TypeScript's build step, TypeScript is translated to JavaScript and all type information is discarded. The type information is only for the developer, not for the JavaScript interpreter. Secondly, type declarations for libraries. When using libraries from NPM, some of them will come with TypeScript declarations included. For example, the Redux library. Most libraries will have separate type declarations packages, which are prefixed with @types. For example, for React, there's @types/React. If we install extra packages, we will often have to install the corresponding type declarations explicitly. So that was an overview covering the essential TypeScript features we will use with React. If you want to look up a reference later, there's a popular resource named the React and TypeScript Cheat Sheet. The link will be in the description.